So, welcome back to the session. We are continuing the concept of forward and futures, and till the last class we discussed how basis risk was important depending on whether there is a mismatch in the actual product which you are trying to buy and sell along with the futures, which is not an exact replica of that spot in room 1 and 2 as I mentioned. Also there may be mismatch in the timing. I need the spot 4 months down the line, continuing with the same example, but my actual forward and futures are only for duration of 3 months. Number 3 can be if you roll over. So, as you roll over, the overall basis risk basically accumulates. So, if you need the actual product around 12 months down the line and the forward and futures are for 3 months, so obviously there would be such 4 different basis risks which will cumulatively add up to give a much more high level of volatility. I am using the word volatility, risk, loss, whatever it is interchangeably. Obviously, we will see later on that if you try to make a subtle difference, there is a difference between them. So, now we will consider that forward prices, how they are calculated and how they are calculated for the cases when there are no coupons are being made, no dividends are being made, if dividends are being made or if dividends are being made continuously compounded, how do you basically find it out. Now, the word of forward and futures which I am saying I am using interchangeably. Conceptually they are same, even though as you just saw in the last class, there are subtle differences of over the counter, not over the counter, being traded such that prices can be dictated by demand and supply, being not traded such that the prices are predetermined. You can close it beforehand, you need not close it at beforehand, you have to basically stick to the time to duration. So, all these things are different and they have a major impact, but when you try to find out the prices of the futures, we will consider first the prices of the forwards, reason being they are held for a fixed duration of time. Based on that, when you find out the prices of the forwards, you can easily find a replica of the futures prices, based on which you can understand how the futures prices would also fluctuate given the same type of forwards are there in the market. Now, we will consider the interest rates. So, consider this data which you have taken is from the State Bank of India in 22nd January 2007. So, these are the 7 to 14 days interest rate is given as 3.75%. I am again not mentioning anything related to per annum or continuous compounded. We will come to that later on. So, if you remember for the interest rate I mentioned time and again, the concept of per annum and whether it is continuous compounded or compounded based on certain time frame or number of times is important, which we will see in few moments. Then you have the 15 days to 45 days interest rate is given as 5, 46 to 179 is given as 5.5 and so on and so forth. So, if you see that the interest rate is in a way a proxy of the overall risk which is happening. So, longer the time duration, more the risk is, and obviously people will demand more interest rate, because if I want to put that money for a longer duration, this money is being locked and being utilized by somebody else if I deposit in the bank. So, obviously the interest rate should reflect such that my overall payback which is happening when I basically close my position or try to withdraw my money should be such that the interest rate should reflect the overall risk which was there for that time duration. And if and for the interest rate detail, you can go to the Reserve Bank site or the State Bank of India or any other bank and try to find out, and considering the duration, how the interest rate change. Now, consider now for the first time the case of how you find out the interest rate. Based on that calculation we can proceed. So, consider an amount A, a principal amount is invested for n number of years at an interest rate of R per annum, and if the interest rate is being compounded only once per annum. So, this is the point which I have been talking about. This is per annum percentage and this is being compounded per annum. So, then the amount of money which you would have is A you had initially. So, the interest rate would now be A into R. So, actual amount which you will get would A is already there plus the interest rate. So, you will basically have A 1 plus R. Now, you consider that if it is being compounded 2 times. So, what you will do is that this is now the actual amount which is being deposited by you at the beginning of the second year. So, obviously, there would be interest rate which is A plus 1 plus R whole square. So, as you continue the because it is 2 times. So, as you continue doing that, you can find out that number of years which is now n. Remember that symbol should be important for you to understand. is the fact that as you do compounding on an annual basis per annum, the total amount of money which was A would now increase to A into R 1 plus R to the power 1 if it is for 1 year, A into 1 plus R to the power 2 if it is 2 years, and so on and so forth. So, if you have 100 rupees which you deposit in the bank on the 12-month period at the interest rate at 8.25 per annum compounded annually, then the terminal value would be given by 100, which is A, into 1 plus R, which is 0.0825 in percentage terms converted into ratio to the power 1, provided you do not take out the deposit any money or deposit any money during the time of 12 months. So, once you put in, you stay put, and then when the time expires, you take out that money. Now, consider the next case. Same amount of money A invested for n years at an interest rate again for R per annum, but now you are basically compounding it m number of times per year. So, what do you mean by m number of times per year? Which means that you will be circulating that money m number of times in that duration of n years or per annum. So, you deposit, take it out after 2 months. So, it will be done for the first 2 month period, then again you deposit at the beginning of the 3rd month the total amount of money which you have got back after 2 months, and then again deposit and get it money after, say for example, 4 months. So, that means the cycle has continued twice, 0 to 2, 2 to 4. Again you take out the money which you get after end of 4 months, you deposit it at the beginning of the 5th month and take it out at the end of 6th month, and you continue doing this. So, if you continue doing such things, so you are compounding in a 1 year 6 number of times, because first is for 2 months, second is for 2 to 3 and 4, next is for 5 and 6, next is for 7 and 8, and so on and so forth. So, if you do the compounding m number of times of year, then actual formula now becomes A into 1 plus R divided by m. So, this rate is interest rate per annum, remember, multiplied by, you already had n, now it will be multiplied by m. So, this is the case where you try to find out the total amount of money which you will get or deposit depending on the per annum case of R and how many number of continuous compounding you are doing. So, if you remember the first formula we did, if continuous compounding is being done for once in a 1 year, m becomes 1, m becomes 1. So, we get back the original formula. So, now if you have 100 rupees deposit for 12 months in interest at 8.25 per annum compounded semi annually, that is twice. So, obviously, this formula would become 0.0825 divided by 2 and to the power 1 is the time duration and 2 is the number of time of compounding you are doing, provided you do not take out any deposit or deposit money and take out any money during the time period of 12 months. Now, consider that how do you want to find out the continuous compounding case, that is being compounded exactly the same thing way. So, actual formula was this. Now, consider continuous compounding means you are doing continuously. If you consider that, the actual value which you will have, there is n here, this is n. So, the actual formula which you will have is as m tends to infinity, it will be. So, this is the interest rate which you have per annum, and this n is the number of years. So, this if you see is the formula which you get using the simple concept of limit. Check any mathematics book, you will find out this formula to be true. So, consider an amount of A invested for n years at an interest rate of R per annum, and with the interest rate is continuous compounded continuously per annum, then the terminal value would be given by this. So, for all your calculations, remember you have to use the continuous compounding rate. So, let me highlight it such that people will be aware of that. So, the value of the continuous compounding interest rate which will be utilized will be, so this formula will be utilized throughout the calculation, and if in case if any rates are given R compounded m number of times or m1 number of times would be calculated accordingly. If you have 100 rupees deposited for again for 12 months, interest rate 0.0825 continuous compounded, then the amount of money which you have is this, considering the fact that provided you do not take out, do not deposit any money within this time period of 1 year. Now, you want to convert any compounding rate to the continuous case or the continuous case to the compounding rate. The concept is very simple. Consider an amount A is invested for T number of years at R1 per annum interest rate continuous compounded. Equivalently, you could also invest that R2 interest rate per annum, but M number of times continuous compounded. And the third equivalence is you are investing in R3 interest rate per annum, but being compounded n number of times. So, do not confuse this n and the n which we did. So, now we will basically replace that n initially which you consider with time period t. So, now time would always be considered by t, and the number of compoundings would be denominated by m1, m2, m3 or n1, n2, n3 whatever it is. Now, if you consider the first instant of continuous compounding, the formula would be very simple, A principal amount into e to the power r1 t. So, this means the total time duration which you have, which is t. So, in that time period the overall amount is this. Now, if you are doing it at a different interest rate of R2 per annum, but being compounded m number of times, so this is the formula exactly the same. So, as m tends to infinity you will get back this. Now, in a third case you consider that it is being done n number of times. So, in this case again the formula remains the same where m gets replaced by n. So, in the case again if n tends to infinity you will get this formula. So, what you are actually interested to know is that if the compounding numbers are given and if the continuous interest rate R1 is given, then you want to find out what is R2 or what is R3 depending on the number of compounding is very specifically mentioned, and also remember the time duration which I have just drawn, which is t, is given in all these three cases. If they are different, then also the calculation can be done without any much problem. So, this is the actual data taken on 23rd July 2007 from Germany and is available in the Deutsche Bundesbank website, which the website is given. And you consider A to be 100 euros, R1 with this continuous compounding interest rate is given by 4.229% per annum. Time duration is 3. So, obviously, if the time duration is 3, as I mentioned, you will immediately convert into a yearly scale for this 3 by 12, the terminal value would be given. The principal amount A e to the power 0.04229, which is the interest rate per annum, into 3 by 12 is the time duration which is given by 101.0629. Now, we consider R2 as the interest rate for the same problem, but is being compounded being done 2 times in a year, that is semi-annual compounding. Consider again time duration is 3, which is 3 by 12, and if you equate this problem, what you have is this value which you have initially you found out is 101.0625. So, you basically equate it to this equation which would have is 100 1 plus this R2 value which you want to find out how many number of times, twice, and what is the total duration is 3 by 12 multiplied by 2, find out R2, that comes out to be 4.274% per annum semi-annual compounded. Again considering you are doing it 4 number of times, do the same thing, A which is 100 into 1 plus R3 which you want to find out how many times compounding, 4 multiplied by time duration remains same, 3 by 12 into 4 which is the number of compounding, equate it to 101.0629 whichever you found out, find out R3 which is 4.2515% per annum compounding 4 number of times in a year. Now, important question is how are the forward and the futures prices related to the spot price? This is the main question, because we have already going to sign a contract FF or for a forward and a futures, and our main concern is to find out that what is the actual relationship between the spot and the futures, which is capital F. So, we did mention about that, we will try to find it out, and this is the stage where we will really try to calculate how the values are illustrated and how they are calculated. So, forward prices are easy to analyze than futures price. Question is why? Main reason, there is no daily settlement for the forward contract, but is present in the futures contract. So, obviously, forward prices are easy to find out, because once given we can find out, given the spot you can find out the forward price. Note, but the prices are very close to each other, hence if the maturity time arrives and if they are both the same, then the forward and futures are same. Hence, to find out the futures price we use the help of the forward prices, and we will see that how it is done. We will analyze forward prices, and that too mainly for the investment assets and not for the consumption assets. This is one of the assumptions which I want to basically highlight. Now consider for our problem the forward prices calculation. These forwards are given by symbol F, the spots are given by symbol S, the risk free interest rate is R with the suffix F or not F, it does not matter, but it should be mentioned that is risk free interest rate continuously compounding. If the compounding interest rates are given something else, we will convert it into continuous compounding sense considering the formulas which we have just discussed. T is the time period in number of years. So, if it is months, we will convert that into number of years, and the suffix are the prices at which they are found out. If it is 0, means this is the prices as of today. Now, the forward price for an investment asset providing no income, so is given by this formula, which is F0 is equal to S0 e to the power RT. Why it is? Because say for example, I want to buy a forward, and another case I do not want to buy a forward, I have that money, and at the end of the contract expires, the amount of money which I have, which I will deposit in the bank, should exactly match the actual forward price, because if it is not matching, then some set of person will go to the bank if the interest of the bank is higher and make extraordinary profit, or some sort of persons will go into the forward market and make extraordinary money if the risk free interest is low. So, if in case in order to preempt that such that the market is exactly symmetric and is equilibrium, we will consider two cases. Either I go for a forward position with a certain price as of today, which is S0, and the forward price increases. At what rate? I will come to that later. Another person does the same thing, but he does not go to the forward market, he basically takes that amount of money which is S0 and goes in the bank and deposits. So, this is kept as a fixed deposit, and the amount of money which the second person will get when the fixed deposit expires at the exact time duration when the futures of the forward expire is equal to S0 into e to the power RT, which is the interest rate. So, now if there is no profit and no loss, the total amount of money which I will get from the bank, or the person 2 will get from the bank, should exactly match the forward contract. In case if it is not, in case if F0 was greater than S0 e to the power RT or less than equal to S0 into e to the power RT, then somebody would make a loss and somebody would make a profit. Hence, the concept of hedging in order to minimize your risk would not come into the picture. So, obviously, it will mean that there is no dividend paying stock, the value of the forwards would be F0 is equal to S0 into the e to the power RT. Consider this, we have taken actual data on 13th of July 2007 from Bank of England. These are what they are. S0 is given as the UK pound, value is 327.518. The in continuous compounding interest rate is given 5.75 per annum continuous compounding, time duration is 6, which is 6 by 12 in the ULD scale, and then you find out the forward, it is S0 e to the power RT, RT is given, which is 0.0575 and T is basically given by 6 by 12. So, now if F0 is greater than S0 e to the power RT, arbitrage buy the asset and short the forward contract on the asset in order to make profit. So, you will understand why I said that if this price was more, then obviously you will buy the asset and short the forward contract later on, such that on this both front you will basically make a difference of the profit based on the prices difference in the asset and the short forward. In case if it is just the reverse, they will just take a reverse position. Rather than buy the asset which is long, you now will short the asset, and rather than go for a short for the forward contract, you would go for a long for the forward contract. So, what you are trying to do, there is a spot and there is the forward. So, in one case you will buy and another case you will sell, and in the next instant if the situation is different, you will sell the spot and buy the forward. So, depending on the price movement of whether F0 is greater than equal to this or less than equal to this, you will take either this position in order to make extraordinary profit. So, again I am repeating, in one case you will buy that asset and short that particular forward. In the next instant when the signs are reversed, you will basically short that particular asset and go long for that particular forward contract. So, these are different. A forward price for an investment asset providing a known cash income. That means, in that duration of time, the total amount of money which you will basically buy is you will get is different. So, now there are incomes which is happening in between. So, this again if we consider should have been S0 e to the power RT, but now S0 has been reduced. What is the amount of reduction? Is the total present value of all the income which I am getting in this time duration. So, this S0 would be reduced by the amount of I or I0, whatever you denote. I0 means the present value of those intermittent payments which is happening at time t is equal to 0 is the present value of all the income of the investment assets. So, now consider you have a time duration is as this, and there are two intermittent payments. So, 0.1, 0.2. So, what you will do is that I try to find out the present value of this, add them up, and that value would basically become I0. So, if I have S0 which is the spot price and also the intermittent actual values of the investment as of today. So, I will basically minus S0, and from S0 I will take out these two values. So, the actual value based on which I will try to forward would take into consideration any payments which will come in the future, because I have converted those payments into the present value which is I naught or I. Consider a 15 month. So, note the data for the interest rate and the actual risk free interest rate has been offered by the being offered by the US Federal Treasury bills as on 19 July 2007. These are actual data and been taken from the Federal Reserve.gov site. Considering a 15-month forward contract on a bond which has a face value of 1000 and the risk free interest rate is given by 4.86 per annum for all maturities, and for that is for all time maturities, even though this value is for 6 months, you know that the coupons, that means the amount of small amount tokens which you are going to get back, each amount is just 3 for this bond are paid after 6 months, after 12 months. The final coupon payment is made after 18 months, which is 12 plus 6, 1.5 years from now. Along with the principal amount, you are requested to find out the price of the forward. So, if you look at it carefully, $3 would be paid after 6 months, $3 would be paid after 12 months, and after 18 months you will be paid the $3 plus the principal amount which you have already paid. So, basically there are 3 different payments. In the first instant it is 3, second instant is 3, third instant is 3 plus the principal amount which you will be getting back based on the interest rate whichever it is there. So, in the first instant if you get, if there was no intermittent, so in the case what we are considering, in the first instant we will consider that this is the amount which you are getting back after 6 months, which is 6 by 12 at this interest rate. Second, again you are getting $3 after 12, and technically which we may consider also, but in this problem I am not considering, is the actual amount of 3 which you are getting e to the power r whatever it is after 6 months, which is 18 by 12. So, this amount of I0 which you found out will be subtracted from S0 in order to calculate the values. So, note if there is no intermittent payment, the value of the forward would be this. That means, this 100 multiplied by e to the power t, but now as intermittent payment are being made, which is this, you convert everything to I0, subtract that from f, and I try to find it out. So, we will continue the discussion in the next class. With this, we will stop here and we will discuss how the forwards and the futures price would be calculated. So, initially we considered no coupons being paid, then coupons in being paid, then we will slowly expand that where dividends are being paid for commodities, such that we will get a better understanding how the forward and the futures market prices are calculated based on the interest rate. Thank you.